Hi, I'm Rainer, and this week we're going to be doing a problem that involves static friction with acceleration. So in this problem, we've got two blocks stacked on top of each other. The bottom one has mass big M, and the top one has a mass of little m. And the top block has force of F applied to the right, directly horizontally on it. And we're told that these two blocks stick together. They don't slip with respect to one another. They move off to the right together. And what we want to do is find the force of static friction between these two blocks. And so we know that this force of static friction is acting right here between the two boxes. So we might say, hey, let's take, say, the small mass and use it in a Newton's second law calculation to find maybe the force of static friction going that way. And so we might do that. We might sum our forces, or rather draw a free body diagram, and say we've got a force going to the right, a friction return to the left, and then we've got a normal and weight as usual. So if I wanted to sum these forces in the x direction, where x is to the right, positive, I might say something like force from u on the mass going to the right minus static friction from big M on little m, which is going to the left. And that's going to equal little m times acceleration of little m. And so at this point, we might be tempted to say, hey, let's plug in mu times the normal force for static friction. And we know that that's wrong because mu times the normal force is only the maximum static friction force. And I don't know necessarily whether this is at its maximum or not. In fact, it's probably not. So the other problem is we don't know what A is. And so we know this F, but we don't know A. And we're looking for this little f right here. So one really smart thing that we can do is consider the system of both the big block and the small block, because in that case, the friction forces cancel, and we can find stuff in terms of stuff that we know. So if we sum the forces in the x direction on this system, we get just one force, Fym, and that equals our system's mass, which is little m plus big M, and then I'll say times the common acceleration, A sub common. And so I can find A sub common. A sub common is, of course, just force over these masses. And this right here, I know that if they're both going at acceleration A common, then block 1 alone must be going with the same acceleration of A common. So I can come back over here, and I can take this guy and plug it in to this acceleration of mass 1. And I can get something like force from u minus static friction equals m, little m, times this acceleration, which is Fyc over m plus big M. And at this point, we're essentially done, because everything in this equation is in terms of stuff that we know, except for what we're looking for, which is this. So if we just go ahead and write it out to be complete, we can say the static friction force equals Fym minus little mass times Fym over m plus big M. And this right here is our answer. So all we did was realize that the two will accelerate together, and since we can do that, we can think of it as one big system moving off as one, and find the acceleration this way. Then come back to the individual system, plug it in for the acceleration, which we know it will be the same as, and solve for the friction force this way. So that's all for this week.